Okay, so we got you. Okay. You hear me? I hear you.
I can hear you. Can you hear me?
Can you hear me now?
Who's not able to join?
I can hear you, Jessica.
Okay, yeah, I can hear you too.
No, there's nobody in the waiting room. We've got some attendees coming in. Did somebody stop that from logging in? All right, gang, bear with me.
Okay. Mm.
Okay, fantastic. As soon as we get Cesar on here, we'll start it up.
Okay. Has the weather improved down there in San Diego?
All right, so we're gonna go ahead and start this webinar. And we're recording just so that everybody's aware. I'm coming in, to you live from the conference, Geothermal Rising. So in case you don't know anything about Geothermal Rising, it's an organization promoting educational opportunities for geothermal, and then Geothermal Rising Student Committee is involved in universities and schools across the country, as well as the world, to allow more geothermal education opportunities at the collegiate level, which may be obvious now that I've said this. But the student competition that we're going to talk about is the spring 2021 US DOE Collegiate competition. And this is something that we didn't really get to see were the results of this work. There were over 15 universities to participate in projects this year. Today, we're going to engage with 3 of the participants. They can talk about their own teams, but Samuel De La Paz is the first one from the University of Notre Dame. He's currently working on a mechanical engineering degree from Notre Dame's engineering department. He's looking at all kinds of sustainability issues and clean energy engineering. And the project that they submitted to the US Department of Energy this spring was called Hole-in-One Heating. I'll let him talk more about that in a minute. The next participant panelist is Jessica Eagle-Bluestone. She's from the University of North Dakota. She's working on energy engineering at the Institute of Energy Studies. She holds a bachelor's degree in geology, so this is funny. She's falling right into the geothermal line, and her interests are geothermal energy. All right, the project that the University of North Dakota submitted this year was called Mandaree, North Dakota, a case study on oil and gas conversion to geothermal district heating systems for rural communities. And finally, the last participant is Cesar Vivas. Hopefully he's able to join us, not currently on yet, but he's with the University of Oklahoma. He's a PhD student at their petroleum and geological engineering department. And his interests are in geothermal reservoir engineering and well construction, as well as machine learning. He's doing a couple of presentations himself. I know Jessica's also doing presentations this week at Geothermal Rising. So we've got a lot of interest, and of course, 15 universities. That's an incredible amount. It's going to be good to get to know what they did, and they submitted this spring. Of course, there's another year-long competition that's just beginning. The initial submission time is November 4th. So if your university is interested in participating in that, get a team together and get something submitted. So I'll start with Samuel. Can you hear me?
Yes, I can hear you. Can you hear me?
All right, Jessica, do you hear Samuel?
I can hear him. Can you hear either of us?
Okay, must just be me. Well, you know what? Since you can hear me, I'll just say, yeah, I understand, Samuel, that the concept for your team was a centralized heat pump with an array under a golf course. This sounds like a pretty novel concept. So I want you to take a few minutes here and just explain to the group what you did.
Yeah, of course. Hello, everyone. Yeah, my name is Samuel, and it's great to have two NDs here on the call, one Notre Dame, one North Dakota. So what we did for our project is when we got into it, neither me nor any of my group mates knew anything about geothermal energy. And so as soon as I kind of saw the invitation to join, and I was really interested in learning about a new form of energy, I got a group together, we did some research, and in that research, we realized that a lot of the big uses of geothermal energy are really used on the West Coast, where there's a lot more tectonic plate activity, and there's a lot of hot water close to the surface that can be drilled and tapped into for heating and cooling, well, heating possibilities. But what I learned about I have a friend whose father is a farmer, and he implemented geothermal heat pumps on his farm to heat his greenhouse and to cool his vegetables. I also learned that my campus, Notre Dame, has 3 geothermal fields already installed and are being used to heat and cool the campus. They currently supply 2% of the heating and 10% of the cooling on campus year round. So with that in mind, we decided to choose the site of our campus to do our project because we weren't really familiar. We knew there were people on campus who knew a lot about it, and we were looking for new ways to see if there was a way to advance geothermal energy on campus. The reason we ended up choosing the golf course is because the cool thing about geothermal heat pumps is that there's a heat pump that is kind of the heat exchanger that exchanges heat from the air circulating in a building with the fluid circulating in the ground that's exchanging heat with the ground. And all of that whole field is all underneath the ground, and you can't really see it. So it's hidden. The only problem is you don't want to build that underneath a building. It's hard to build it underneath a building, and you don't want to put it on a piece of land that eventually will turn into a building. Right now, we currently have a geothermal field underneath a parking lot by our football stadium, another one underneath athletic fields, and a third one, smaller one, underneath a campus quad. So this one, we thought by temporarily tearing up one of the golf course holes that are right by our campus, which are only used by staff and students. So it's not really a real profit gaining business. It's more for university use, that we would be able to turn that section into a geothermal field with the potential for expanding further and further into different holes. And in doing that, kind of when that top is replenished, that green is going to be better for the golfers. It's going to be newer grass, better shrubs, and also more clean energy for our campus. And that's a little bit about our project.
Great, thank you. Forgive me while I fumble around with my own audio. So it seems that while I'm talking to you, I can't hear you, but that nonetheless, I'm gonna go ahead and introduce Jessica. Again, allow her to discuss her own project, but I'll just give you a brief summary. It was a petroleum well conversion assessment for domestic hot water and space heating in Mandaree, North Dakota. So you were really the guide on bringing this idea to the group. Do you want to tell us about what you did to come to this conclusion that this community was the right place, and then go ahead and give us a summary of the project overall?
Okay, so I wanted to look into district heating in Mandaree because I'm from the area. It's located on the Fort Berthold Indian Reservation, which is the same reservation that I'm from. It's a small town, and about more than 50% of the population live in poverty. It's a food desert. The closest grocery store is 30 miles away. So finding a way to access more nutrition, more nutritious foods is something that is really important to the community. And that's one of the things that we looked at in this project, was creating an additional heat load in order to support commercial greenhouses. There's a tremendous amount of oil and gas activity surrounding Mandaree. So we had access to several candidate wells for conversion. And the community itself is interested in developing renewable resources. Definitely, they would like to move away from fossil fuels, and this project would help them do that. It would offset 2,735 metric tons of CO2 equivalent a year.
All right, fantastic. Thank you, Jessica. And we'll get back to that community engagement piece, because increasingly that's becoming an important part of where geothermal is going to go. We have to sell this stuff to the public if it's going to create that inflection point where people adopt geothermal as one of the primary energy sources going forward into the future. So Cesar, are you there with me?
Yes, can you hear me?
Yes,
can you hear me?
Thank you, Cesar.
Okay, I'm
another.
Yeah, no, yeah.
I'm sorry.
No, I'm so sorry. No, I'm so sorry because my computer, I don't know what happened, but failed. So I tried to connect since a couple of minutes ago. So yeah, okay. My name is Cesar Vivas from University of Oklahoma, and our project was based on using existing wells to provide energy to public schools, to elementary and high schools in Oklahoma. And the reason of this project, okay, it was okay. We are looking for for a way to use the geothermal energy. However, Oklahoma is a place with a low enthalpy, geothermal gradient. So the first approach, we said, okay, we need probably look into did use application. So one of the things is I am a parent, and I have two kids. One of them is 8 years old, and we met with other parents, and we complained that there are a lot of wells that close to some schools and even facilities that what our kids use for playing and doing things. So the idea was, okay, what not to use those existing wells to provide energy, and okay, instead of those wells have the perception to create pollution. So, okay, why not to use those wells that are, a source of pollution, and convert those wells into have a green application for using renewable energy. So basically, what we said that is, okay, one of the main constraints that geothermal energy has is the capital cost, and and the cost, a high source of cost is the drilling process. So why not to take advantage of existing infrastructure? And there is nothing more green that reuse things. So reuse resources makes sense. Is part of recycling materials and things. So we use those the concept of using the existing infrastructure, and we reevaluate the concept of collecting information of reservoir information, see how the wells can, the connectivity of the wells, and aquifer that the wells that we selected, okay, those wells share the same aquifer. So basically we go through the engineering process and see that we prove that at least in the technical standpoint, that selecting wells in a low enthalpy environment, if you are enough deep, you are able to use those wells to provide energy.
That's fantastic. Yeah. And you mentioned the technical piece, of course, but what was also standing out there was that it's stakeholder engagement. So we keep going back to that stakeholder engagement. So I want to go to Jessica now. So we're talking about this geothermal direct use business model. All right. That was the contest. This was constrained to a geothermal direct use idea. So that was what the collegiate teams had to come up with. Is that the community model? Is that what's going to, entice private utilities to start adopting geothermal energy? How do you think that looked on your assessments this year?
Yeah, I think it will be the communities pursuing it first. It's really the population that's going to drive what resources they want to use if they want to try to get away from fossil fuels. It's definitely up to community members to kind of push for renewables, and hopefully specifically geothermal.
Yeah, great. Thank you. And so I'm going to turn back to you, Cesar. So these are both oil well conversion ideas, right? Recompletions or completions to new formations. So what complications did you find on the technical side, right? I know you're on the technical side. Tell me more about the reservoir engineering complications, and what would you expect to encounter as problems?
Okay, the first thing is to analyze the connectivity of the wells, because you need to see that they are, basically connected. The thing that the water that you inject from one well effectively be produced, in the other well. So using existing wells have different constraints. The first one is just obtaining the data. Some of those wells are very old, and you need to obtain data is a little bit difficult. Also, we have evidence, and at the University of Oklahoma in the Well Construction Technology Center, we recently did a workover operation, and we retrieved some of the existing tubing, and we said that that was badly affected by corrosion. So some of those wells needs to be tested, and essentially we need to consider that most of those wells potentially have corrosion problems. So and those geothermal projects are long-term projects, so you need to consider the well integrity of those wells. So basically there are different operations and different well interventions that needs to be done to address especially corrosion, because as this operation requires a constant injection and producing process, we need also to consider those things. So for me, that is probably the more in the physical, in the wells standpoint, the most important thing, the well integrity. And in the reservoir management, probably this is more simple because as I mentioned, we found that the wells or the wells that we choose share the same aquifer and a similar depth. So probably because they belong to the same development, the same oil and gas development. So in that case, the model work.
Great. Yeah, thank you. And finally, my headset is working well again, so I'm glad for that. And thank you for the great answer. I really like this concept. I've heard it recently at the conference, actually, of just twinning the well. So you take the oil and gas well, even if it's a terrible, technical problem to overcome, you can use all that geologic data and twin it, drill new right next door. Of course, with district heating and direct uses, that might not always be economic. So just one last time, I'll turn to Jessica before I again go back to Samuel. Jessica, can you say for certain, does the community in Mandaree, for example, are they thinking about direct use? I mean, are they really thinking about space heating and cooling, or what would the first product that they're looking for be? Can we do both of these things at the same time? And are we going to be able to sell the public on that?
I think so. The community leaders that I've spoke to are definitely interested in direct use. They are a little bit more interested in electricity, but they are also interested in the direct use concept.
Great, thank you. And so Samuel, you're the guy, your team, Notre Dame, they were implementing heat pumps, geothermal heat pumps, right? So it's not just a one size fits all. We've got everything from an oil well conversion idea. We've got new drilling concepts, and we can do what they call closed loop with underground storage using earth as a battery, correct? With these geothermal heat pumps. Can you tell us more about what heat pumps could mean for the industry, and which one is probably going to be more frequent in the United States, for example, or North America?
Yeah, that's a great question. And I, from the limited knowledge that I have of heat pumps and the market trends, I know that about like 75% of geothermal heat pumps installed in the US are for residential applications. So for individual houses and homeowners, or for apartment complexes, where the other 25% are for other uses. And in total, right now, geothermal heat pumps only account for 1% of the US HVAC market, which is very small. But when you look at the map of the United States, historically, there's been a ton of heat pumps that have been, the majority have been concentrated around Ohio, Pennsylvania, and kind of the upper Midwest. And there's also a lot in Florida, a lot in Texas, and a lot less in the western part, where direct use would be more, more probable to be used. So I think I know that the Department of Energy, on their website and on their materials, they continually advocate for how great of a potential geothermal heat pumps are. According to the EPA, they can reduce energy consumption 44% compared to air sourced heat pumps, which instead of exchanging heat with the ground, they exchange heat with the air. And they also reduce energy consumption 72% compared to electric resistance heating and other standard air conditioning equipment. So there's a huge potential for reduction, not only in electricity usage, but also in greenhouse gas emissions. And I'll say that with heat pumps, they do save a lot of money. They are a big capital cost, which Cesar was talking about earlier, but they do, over the studies are between 5 and 14 years, they do end up paying for themselves. And so really in order to accelerate this transition to more new developments being geothermal, we should continually talk about the incentives of how much can be saved over the long term. And to correct what I said earlier, it's 75% of residential heat pumps are for new construction, sorry, not 75% are residential. Of the residential ones, 75% are new ones and 25% are retrofitted systems. So yeah, I think we can continue to advocate, spread the word about it. There can be a big increase.
Yeah, fantastic. Thank you. And yeah, so you mentioned, this is basically like beneficial electrification, correct? And so that idea is to, stabilize that peak load, that peak demand across points, and then add renewables on it. And of course, one of those renewables itself could be geothermal. So not only are you electrifying with geothermal, you're adding renewable electricity with geothermal. So these two worlds collide, and then we can combine heat and power even in some optimal locations. So I'm going to stay on you, Samuel. What brought you to sustainable energy generally? I mean, and then what kind of drew you in like a fly to geothermal in this case, if we hope to get you there?
Yeah, it's a great question. Throughout my, I guess, college career, I knew I really wanted to do something with engineering. I loved math, loved science, but I also wanted to apply it. I didn't really want to just kind of do the theory side of things. I wanted to see it implemented in the real world. And I also have really strong values for serving my community and doing things to help people, help or to contribute to the common good. And that's where I found the energy industry to really bind those two things together, combining energy expertise with a public utility that serves a diverse set of applications, along with the threats of the climate crisis and how the transition to clean and renewable energies is becoming more and more important. And so that's where I've kind of found myself really digging in deep. I've had some experience in the wind turbine industry this past summer, but leading up to that, I had heard of solar, I had heard of wind turbines, but geothermal, I had absolutely no clue. So the thing that really pulled me in was, one, it was a collegiate competition. It only lasted for the semester. It sounded exciting. And two, I was really excited to learn about something that I really had no idea about, and now I can see the potential. And I've also brought it to my school. The people in charge of the energy studies department also had very little experience, and now they've really come to inform themselves more on the topic.
Yeah, that is fantastic. And just for just to reiterate here, Samuel he's coming in with he's got a bachelor's, and he's coming in, he's looking at getting into this right now. I mean, a lot of us, maybe we didn't follow this same path. So now I want to turn to Cesar, who, Jessica and Cesar both have experience in the oil and gas industry. So they, the path isn't always a straight one into renewable energy. Cesar, can you talk more about what drew you in to geothermal? What drew you into sustainable energy? Are you there, Cesar? You might be on mute.
Yes. Yeah. Can you repeat that, because the sound was okay. I lost the sound for a moment.
Okay.
So
yeah. So what drew you in, coming from an oil and gas background, what drew you into sustainable energy? What drew you into geothermal?
Okay. If I understood well, okay, I'm sorry, the sound is not very good, but okay. Being, when you come from oil and gas, you understand that all the techniques and the science behind development of an oil and gas resource basically share the same science and needs, needed in geothermal energy. Okay, let me just rephrase this. Is, for geothermal energy, you need to drill wells, you need to do reservoir engineering, because you are harvesting harvesting energy, but this energy is not comes from oil and gas, oil barrels of oil, but instead you are harvesting heat. But in essence, you need to do the same thing. You need to do drilling, well completion. You need to have a reservoir management. So basically, all of the skills that you develop in oil and gas industry are easily transferable to geothermal energy. And geothermal energy, if you see in a human lifespan scale, is renewable energy. So in this moment we are in a full intention, not only the oil and gas industry, but also the government and different institutions and even the community, to move into the energy transition, the decarbonization. So for us, petroleum engineers, makes sense to switch, or geothermal. The skills that we learn in oil and gas are easily transferable for geothermal energy development.
Yeah, that's great. It's a natural transition. A lot of people are talking about that these days. Where is the industry, the oil and gas industry, going to turn? And what mechanisms can they apply to a sustainable market? Whereas in the past, there's been obviously some dissection or divergence from that. So Jessica, can you tell us a little bit more about what you gained and what your team probably gained from this collegiate competition as a whole? I know this was a collaboration between the University of North Dakota and Reykjavik University. What did you learn? What did they learn?
A lot. I think we gained a lot of real world experience. Things from engaging with the community, getting quotes for all of the equipment that we're going to need, and running all the simulations that would go into actually developing the project. So these are things that you typically don't learn in a classroom. And it's just a great experience to go out and develop these skills, which we otherwise most likely wouldn't have just in our regular college experience.
Great. Okay, that's fantastic. And this is carrying through, right? So I understand, I'm on your team, so we're participating in the next round, which is the 1-year competition, which people again are still allowed to sign up for. So if your college hasn't signed up for it by November 4th, you'll want to do that and get a proposal ready. But what about education opportunities? I just want to stay on you, Jessica. What about education opportunities in the US for geothermal? What did you find when you came from geology to energy engineering at University of North Dakota?
Yeah, so I worked in petroleum before I switched to geothermal, and I was actually a petroleum engineering student at the University of North Dakota. I looked around a little bit for for geothermal schools when I decided to switch, and then realized that I was actually already in a pretty good place for it with Dr. Gosneld. So I decided to stay where I was, and there isn't a clear path for geothermal students. You kind of have to cobble together your own plan, which is wonderful. It would be nice if it was a little bit more clear, but I think that it's also great to kind of focus more on what your interests are, and develop the plan that you think will be most beneficial.
All right, great, thank you. And Samuel, how about you? Do you think, are we there yet with the U.S. education system for geothermal? Should we be talking about it more or less now that you've participated in the competition? Tell us about it.
That's a great question. I'll have to say that when we were looking for an advisor here at my school to help with geothermal, we were looking around and everyone was like, yeah, a lot of the professors here were like, yeah, we don't really do geothermal energy. I mean, they couldn't put us in the right direction. The person that we did end up working with was the utilities assistant director who had worked with the whole geothermal project and the geothermal heat pump developers when they had come to campus. So he was really our source of education. I mean, the first 2 weeks of working with them, I think, was just getting over a giant learning curve of understanding like I never heard of tons of refrigeration before. It was always, either BTUs or watts. And so that educational process, I kind of felt was left out of some of my education. I think that for me as a mechanical engineer, we take a heat transfer course. I definitely think that more examples using geothermal systems could be implemented to put it on the students' radars. I think that also in the lower primary education system could also be talked about. I think a lot of times when people talk about renewable energy resources, they talk about wind and solar, and then they'll talk about nuclear, like, well, it's a good idea, but right now there's not a lot of public support. And then they'll mention geothermal and biogas and other things as though they're just these things off to the side, because that's the big thing. Geothermal doesn't look, at least heat pumps, they don't look cool. You can't see them. They're either underneath the ground and the heat exchanger is inside of a building. Whereas you can see a nice solar array, or you can see giant wind turbines and say, hey, look what they're doing for renewable energy. So really, I think that the university's done a good job of talking about it. I think they can talk about it more. And I think that we should continue to talk about it as one of the potential ways to get to net zero emissions, not just with electricity, but also understanding the amount of energy our buildings take with heating and cooling. That was something that I really didn't understand leading up to this. And so I've gained a deeper appreciation for that.
Yeah, thank you, Samuel. That's the Geothermal Rising as an organization struggles with that as well. Getting public awareness, public participation, and this is why they've rebranded from Geothermal Resource Council, which was a very abstract concept for people, to Geothermal Rising. In other words, we're getting heat from our beneath our feet, right? That's what we've got to sell to the public, and it's a difficult concept. So I'll just stay on you for a second. Where are you going? Are you going to stay in sustainable energy? Are you going to try and tease out a path in geothermal?
Something that this project showed me is I really enjoyed seeing the big picture of seeing where are we going? What kind of energy are we looking at? Where do we want to put it? Or better yet, what community are we looking at and what kind of energy is going to fit their needs? And then going from there to engaging with the stakeholders to implementing the project. So I think something that I'd be really interested in pursuing in the future is to be on some kind of energy development group, maybe within geothermal, maybe in a group that does geothermal, solar, or other electrical applications, concentrated solar. There are a ton of options. And so I think going on that project side of things is something that I'd be really interested in.
Great. And I appreciate that. Integration is going to be the key going forward. Where if you're not looking at a world where you're having integrated energy, renewable sources, then obviously, if you're just stuck on solar, then it's not going to be feasible for the entire world. It's not going to translate to every region of the world. And that's what we have, the task ahead of us. So, hey, Cesar, I want to turn the same question to you. Are you you're coming from petroleum? You're in the middle of your PhD program, right? So what are you thinking? Are you going to be able to make a home in geothermal?
Yes, I think so. Absolutely. And personally, this is a personal intention, to remain, as I said, all the skills that you develop in oil and gas industry are easily transferable to geothermal energy. So initially, that makes sense. Second, this industry has just one direction, is to grow. Okay, in this moment, there are different factors that are, that are helping to encourage, the massive spread of geothermal energy. Also, geothermal energy is really a really appealing renewable resource. This one of the things that are probably difficult about renewables is the capability to provide a base load. Okay, let's say constant a constant generation of energy. Geothermal is not affected by seasonal factors, so definitely, geothermal makes a lot of sense to be developed, and I think that this industry is going to grow. So now, in this moment, is small, but definitely this is going to be a source of employment, and definitely probably is the direction that we need, that is, for some of oil and gas professionals, is a proper direction to move. So absolutely, no, my intention is to remain. I want, and there is also a passion that behind this. So yeah, I am starting, being affected by this passion. I found that I am really enjoy to be involved in these geothermal developments and anything related to geothermal.
Yeah, that's great. Yeah. So a passion is driving you, and it's, kind of almost a perfect fit for a transition. And we can do this with jobs, right? So we're delivering. Geothermal has the ability to deliver, whether it's the plumber or it's the driller or it's the petroleum engineer. So I'm going to turn now, final question here to Jessica. What advice can you offer to fellow students, upcoming students, how they can get involved in the geothermal energy industry, and more broadly, sustainable energy?
How they can get involved in geothermal?
Yeah, wherever they find themselves. Do they have to find the right university? Are they going to find the
Yeah,
right
definitely.
professor? Or
So
what's it take?
find the right professor. So that seems to be the main way to get into studying geothermal in the United States is find a professor that's doing research that you're interested in and reach out to them.
All right, great, fantastic. And we know we have a worldwide audience, so it varies, like what it takes where you are. And we're going to continue this series, Geothermal Talks. Hopefully somebody with better tech skills than me is going to run it, and we'll have some global perspectives. But I want to thank you all for your time, and I really appreciate it. These are fantastic projects. We were supposed to do a Kahoot quiz, but I think our attendee list is a little low for that, but this recording will be made available. And so again, thank you all for your time. And just remember that if you, as a watcher of this video, are not yet a member of Geothermal Rising, there are free and reduced rate memberships available. You can contact the Geothermal Student Committee, get in touch with us on geothermal.org, or contact your local student chapter and join us, because we're here for everybody, and we'd love to have you. So again, thank you. Before I close this out, really great work. And yeah, please, thank you for the inspiration. It was fantastic. Continue to spread the word.
Thank you, Nick.
Thank you. Bye-bye.
Thanks for having us, Nick. Bye, everyone.
Yeah, thank you so much.